Hello, welcome to this video. In this video, we are going to be talking about sector of a circle. So we'll be dealing with sector of a circle, and we are going to have about 5 videos on talking about sector of a circle. Then our lesson 1 is area of sector, lesson 2 is radius of a sector, and then in lesson 3 or video 3 is going to be area of the sector. Then video 4 is going to be length of the arc of the sector, and then video 5 we are going to talk about how to calculate the perimeter of a sector. So please check the description of this video for other video on the sector of a circle. So now let us start with lesson 1, which is area of a sector. So welcome to lesson 1, which is area of a sector of a cycle. Now the meaning and description of a sector. Number 1 is this: a sector is a part of a circle bounded by 2 radii and an arc. Now we have a circle here, and this is the center of the circle. Now, if this circle is bounded by 2 radii, that is, let's assume that this is one radius, and then this is the second radius now. So the shape we are having here now can be described as the sector of the circle. By the time we extract this shape outside, we are going to have something like this. So our sector we're going to be like this. So this is what we call the sector of a circle. And as you can see here, the sector of a circle has the angle that a sector subtend is usually known as the theta, and then this is known as the radius of the sector, and also this is the second radius, and then the distance from here to here along the circumference of the circle, this is known as the arc of the sector. So these are the parts that a sector of a circle can have. A sector usually has 2 radii, an angle, and then an arc. So we are going to see how to extract or derive a formula for the area of a sector. Let's quickly do that now. Area of a sector, the formula. Now, the area is equals to, now if you look at this place, we have an angle here, and this angle, and the angle there is, so we are having an angle here. So to find the area of a sector, is going to be the angle that the sector subtend over the total angle of a circle is 360. That is theta over 360. Then multiply by, since we are finding the area of a circle, that means that we are going to multiply by the area of the circle, which is pi r square. So actually, this is the formula for finding the area of a sector. Area is equals to theta over 360 multiplied by pi r square. So the r here stands for the radius, this is the angle, and then this a stands for the area. Now we are going to solve some 2 problems on finding the area of a sector of a circle. Number 1 problem says that calculate the area of a sector of a circle which subtend an angle of 45 degrees at the center of a circle of radius 14 cm. So circle of radius 14 cm. So we are going to solve this problem right now. First of all, let us write out the parameters we can see in this equation. The parameters we can find out of this equation include the following. We have seen from the equation that the theta, the angle that the sector subtend at the center of the circle, is 45 degrees, and then the area, the radius, is given to us as 14 centimeter, and then we are now asked to find the area. So area is going to be what? Theta over 360 times pi r square. Now we know that this actually is a WAEC equation. This is a WAEC equation. Let us solve it together now. Theta is 45 degrees over 360 times our pi. We assume our pi to be 22/7 times the radius square. That is going to be radius, that is 14 centimeter square. That is 14 cm times 14 cm. If you have to write it this way. Now we are going to simplify this equation to the simplest form. Here we see 14 into 14 is 1, and 7 into 7 is 1, and 7 into 14 is 2. So, and then Also, at this stage, we are now having a 45 degree times 22 times 2 centimeter times 14 centimeter, all over 360, all over 360. So if we, of course, in this place, we know that 45 can go into 360. 45 into 45 is 1. 45 in 360, it gives us 8. So we are now left with 22 times 2 times 14. 22 times 2 is 44. 44 cm times 14 is going to give us 616 centimeter square over 8. By the time we divide 616 cm by 8, we are going to have 77 centimeters square. So, and that forms the area of the sector. Now we're going to solve one more problem on the sector of a circle. And the second problem here says that the arc of a circle of radius 20 cm sustain an angle of 120 degrees at the center. Use the value 3.142 for pi to calculate the area of the sector correct to the nearest centimeter square. This is actually a WAEC question, that is West Africa Examination Council. So let's solve this problem together. First of all, we can try to draw this sector and see. We are going to have something like this. The radius from this equation, so that the radius is 20 cm. Here too is 20 cm, and the angle subtended at the center is 120 centimeter, sorry, 120 degree. So now our area of a circle is going to be theta over 360 times pi r square. So our theta is this, which is 120 degree over 360 degree times the pi that we're given here is 3.142 to be multiplied by 20, that is the r square, that is 20 cm times 20 cm. So if you simplify this, 0 go with 0. Also, we can have 12 into 12 is 1, 12 into 36 is 3. So we are going to be left with 1 times 3.142 times 20 times 20 is actually 400 centimeters square over 3. So if we solve that, we are going to have 418.93 centimeters square. If you multiply this and divide by this, you're going to have this. But since we are told that we should round it up to add it up to the nearest centimeter, so the nearest centimeter here is what? If you round 9 up to this, then 8 becomes 9. So we are having 419 centimeters square to the nearest centimeter square. So this is actually the solution to the problem. Thank you for watching this video. Now join us in lesson 2 of the sector of a circle, which are going to talk about the radius of a sector. God bless you. Please subscribe to this channel for further videos.